Divisibility rules are very, very useful. You will find that you will use them when you're doing mostly anything with fractions. Simplifying, converting from improper to mixed, adding, subtracting, multiplying, and dividing. Even when you get into intermediate algebra, when you're trying to factor an expression, knowing these rules and how numbers go into other numbers would be very useful. Anyway, a number is divisible by 2 if it is even. In other words, an even number is a number that ends in 0, 2, 4, 6, or 8. So 124 is divisible by 2 because it ends in a 4. A number is divisible by 3 if the sum of the digits is divisible by 3. This is really useful. Take the number 258 and add the numbers 2 plus 5 plus 8, you get 15. 15 is divisible by 3, so 3 goes into 258. If you didn't know that 3 went into 15, then you add 1 plus 5, and so on and so forth, and it goes in 6 times, so yes. It doesn't tell you how many times 3 goes into the number. It just tells you that 3 does go into the number. A number is divisible by 5 if it ends in a 5 or a 0. So the number 495 ends in a 5 and 620 ends in a 0. So both those numbers are divisible by 5. And a number is divisible by 10 if it ends, simply, if it ends in a 0. So 980 is divisible by 10 because the last digit, or it ends in a 0. Okay, more examples. All of these numbers are divisible by 2, and you can see that they end in a 0, 2, 4, 6, or 8. 8, 2, 4, 6. It doesn't matter what the digits are ahead of the last digit. As long as it ends in 0, 2, 4, 6, or 8, if it's even, then it's divisible by 2. 5 is simply if it ends in a 5 or 0. 15, 35, 90. Doesn't matter how many digits you have, as long as the last digit is a 5 or a 0. 10 is even easier. If it ends, last digit, doesn't matter how many digits you have, if the last digit's a 0, then the number is divisible by 10. And I put this one last because it really is the most useful. Most useful. Add up all of the digits. 2 plus 7 is 9. 3 goes into 9. 5 plus 4 is 9. 3 plus 2 plus 1 is 6. 3 goes into 6. 3 goes into 321. 954. Here's a good one. 1 plus 1 plus 1. All of these 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 goes into 9. 3 goes into that number. Again, it doesn't tell you how many times 3 goes into that number. It just tells you that it does. So here's some that I want you to try. Put this on pause and see how you do. All right, 75, it ends in a 5, so we will know right off the bat that it's divisible by 5. If we add up 7 plus 5, we get 12. Aha, so 3 goes into that number. Not easy to write with this. 120, let's see, it's even, so 2. Ends in a 5, ends in a 0, so 5. Ends in a 0, so 10. And then if I add 1 plus 2, I get 3. So 3 also goes in. 80, it's even. It ends in a 0, so 5. Oops. 10. 8 plus 0 is 8. No, 3 doesn't go in. 68, it's even. Let's see. Doesn't end in a 5 or a 0. And if I add up 6 and 8, I get 14. Now, it just so happens that there are other numbers that go into 68. It's not prime. 2 goes in, it's even, therefore it's not. Anyway, we'll talk more about that in the next video. 73, it's not even. Doesn't end in a 5. Doesn't end in a 0. Oh, it ends in a 3. Does that mean 3 goes in? No. What's the rule for 3? Add them up. 7 plus 3 is 10. 3 doesn't go into 10. So, nothing. No numbers go in of this list. Actually, no numbers at all. 51 is one of my favorite numbers. It's not even, doesn't end in 5, doesn't end in a 0. But if you add up 5 plus 1, you get 6. So 51 is not prime. 3 goes in. It goes in 17 times. Doesn't matter. All we know is that 3 does go in. 900, okay, it's even, ends in a 0, ends in a 0, and 9 plus 0 is equal to 9, so 3. And 87 is another tricky one. Not 2, not 5, not 10, but what's 8 plus 7? 15. And again, if you don't know if 3 goes into 15, add 1 plus 5. 3 goes into 6, so 3 goes into 87. Now there's some more rules. There's a rule for 4, 6, 8, 9, but honestly, you don't have to worry about them. Maybe in future classes it might become useful to tuck in the back of your head. But if you're reducing a fraction, if you've got the fraction, say for example 24, and you want to know, who cares if 4 goes in? We know that 2 goes in 12 times, and then 2 goes in again. So you just keep breaking it down. Numbers divisible by 6, this might be useful. If it is even and if 3 goes in. So here we have the number 324. It's even, and if I add up 3 plus 2 plus 4, I get 9. And 3 goes into 9. So 6 will go into that number 324. The number's divisible by 8 of the last 3 digits. So again, doesn't matter how many digits you have over here to the left. All we care about is the last 3 digits for an 8. And 3 goes into 848, so we'll go into 32,848. 9 is pretty useful. You know, you get a number like 27, and you can't remember if 9 goes in, but 2 plus 7 is equal to 9, and 5 plus 4 is equal to 9 for the number 54. So it's good to know the 9 rule for those reasons. But again, you're not going to get anything this big to have to reduce two numbers. But it's still useful. So you add up 6 plus 5 plus 7, and you get 18. And 18 is divisible by 9, if you didn't know that. Once again, add plus 1 plus 8, you get 9. Now there are other rules for 7, and there's some other tricky ones. But we're not going to worry about those right now. This workforce product was funded by a grant awarded by the U.S. Department of Labor's Employment and Training Administration. The product was created by the grantee and does not necessarily reflect the official position of the United States Department of Labor. The Department of Labor makes no guarantees, warranties, or assurances of any kind, express or implied, with respect to such information, including any information on linked sites and including, but not limited to, accuracy of the information or its completeness, timeliness, usefulness, adequacy, continued availability, or ownership.